Okay, I forgot to talk about this part, expected value of a function of a random variable, before the section which was about, let me see, mean and variance of a linear function of a random variable in lecture 3a. So let me talk about this part. This part basically says that when you have a deterministic function of x, this may be any function, like a nonlinear function if you like, for instance, something like that, doesn't matter, then the expected value of this function can be found in this manner using this equation. And we have already used this equation for linear functions. If you recall, we said that if the function is in this form, then we find expected value to be equal to a times b expected value of x, and variance is going to be equal to b square variance x. These are the results of the next section, but before that section I should have talked about this. So this part, the one that I'm talking about currently right now, is the more general result. Even if you have a nonlinear function, it doesn't matter, the expected value can be always found in this manner. So as an example, let's take this one. Let's say that we have 3 cards, 1, 2, and 3, and the probability of, let's say, picking those cards randomly is shown with this probability mass function. So it's a discrete probability mass function with 3, x can take 3 different values. Support of x is equal to 1, 2, and 3. And we have a cost function or a profit function, let's say, but depending on the card that we choose, we pay this much money or we are given this much money, let's say. Then the question is, if this is our profit, let's say, call it profit, note that x itself is a random variable. It may take 3 different values. Therefore, profit itself will also be a random variable, although we have this deterministic or constant 10 value. So now the question is, what is the expected value of our profit? Hence, in mathematical terms, it's going to be equal to expected value of hx. And using this equation, we can easily show it by this fashion. So this is over domain of x or support of x multiplied by the value, the deterministic function value at these support points multiplied by the corresponding probability mass function value. So we have 3 values. It means h1 multiplied by probability mass function of 1, h2 probability mass function of 2, and h3 probability mass function at 3. Now h1 is going to be equal to, since h is given by this formulation, so h1 is going to be equal to 10 times 1 square times f1 is equal to 0.2 plus h2 is 10 times 2 square multiplied by f2, which is 0.5, this value here. And the last one is 10 times 3 to the power 2 multiplied by 0.3. And if you do the whole calculation, I'm going to copy here. I think the result is going to be equal to 49. So this means the expected value from this game, expected profit for this game is going to be equal to 49.